Hi everyone, my name is Liang Huang, and I'm Dr. Joshi's last PhD student. I'm deeply saddened by Arvind's passing, and I'm honored to speak here about his legacy in computational biology. So most people have known Aravind as a pioneer in computational linguistics, but not too many people have known Arvind's work in computational biology, which are also very important. So here's my story. So technically, I was not the last student to have graduated, but I was the last who have entered the program. So in the Chinese tradition, this is called a shut door student, which means the advisor shuts the door and admits nobody else. But naturally, as the last student, I should have bared some special responsibility for passing on his legacy. Indeed, I did, because the direction that Aravind assigned me for my thesis was very different from everybody else's. This was because around 2001, Aravind discovered a brand new direction, and he was super excited about it, where he can apply computational linguistics to structural biology. So this direction was featured very heavily in his award address when he received his ACL Lifetime Achievement Award. He discovered that there are a lot of correspondence or parallels between linguistics and biology, where in linguistics, you have sentences like the chef cooks the soup, and you have syntactic structures represented as parse trees, which can also be modeled by context-free grammars. In biology, you have also sequences, but instead of English or Chinese sentences, you have RNA or protein sequences, which are made of nucleotides or amino acids. And above the sequences, you also have structures. And the simplest structure is called secondary structure, which can be represented also as parse trees and modeled by context-free grammars as well. But more interestingly, the tree-adjoining grammars, which Aravind was known for, which can model crossing structures in natural language, can also model crossing structures in RNA and protein. And that reminds Aravind that this might have a great potential by connecting these two fields. So he wrote an NSF proposal. It was funded, and he started to recruit students and postdocs for this project at Coding 2002. So I applied, and he accepted me and brought me to Penn. So this project involved 2 PhD students and 1 postdoc at Penn. David was the other PhD student, and Julia was the postdoc. We had great collaborators in biology at UCSF. So Ken Dill is basically the Aravind Joshi of protein folding. And we published papers in JACS, Polymer, Proteins, and other journals. But unfortunately, at the end of the project, David, Julia, and I all went back to focus narrowly on computational linguistics and no longer work on biology. This was much to Arvind's disappointment because we did not realize, as much as Aravind do, the great potential of this interdisciplinary direction. But things took a very interesting turn after I moved to Oregon State. So I did not work on any biology after 2007. But after moving to Oregon State, a colleague of mine who is a biology person working on RNA structures asked me, do you happen to know like this very complicated term called stochastic context-free grammars, which can be used for RNA secondary structure prediction? I was like, wow, this was what my advisor wanted me to work on for my PhD. But much to his disappointment, I abandoned that direction. I went back to natural language processing and focused narrowly on that. But this conversation reminded me that now, after working on natural language processing for so many years, I could come back to biology. I could apply what I've discovered all these years in computational linguistics, and in particular, linear time parsing algorithms, to speed up RNA and protein structure prediction. Because, interestingly, the standard algorithms for RNA secondary structure prediction is indeed the CKY algorithm, which we invented back in the 1960s in computational linguistics. So they were always about 20 years behind computational linguistics. So I immediately realized the great potential of this direction, and I worked on it for the past 2 years and got great results, and we got the first linear time predictor for RNA secondary structures, whereas all the existing ones are cubic time based on our CKY parsing algorithm from 1960s. But more importantly, the more I work on this direction, the more I realized that Aravind was correct from the very beginning. He was correct 15 years ago when he would try to convince me to work on this direction. That this direction has probably more potential and more importance than computational linguistics itself. But now it's my turn to convince my own students to work on this interdisciplinary direction, and it remains a difficult task, just as it was a difficult task when Aravind tried to do that about 20 years ago. So thank you, Aravind. It was a great honor to be your last PhD student, and I will continue this direction of applying computational linguistics to structural biology in your honor, and I'll make sure I pass on your legacy to your academic grandchildren. Thank you, Aravind, and thank you everybody for your attention.